All right, so my name is Pascal Heus with a group or company called Metadata Technology in North America. Not to be confused with Metadata Technology, which is a UK company. We used to be one company many, many years ago, but we ended up in two different spots. Our group is based in the US. Most of the team is in Knoxville, Tennessee. I'm personally in Calgary, Canada. For those who don't know us, we've been working for many, many years with National Statistical Agency, international organizations, standard setting projects, and government organizations to modernize infrastructure and data management practices around statistical data, mainly official statistics and research data. We worked a lot with, right now we work a lot with Stats Canada, Stats New Zealand, lots of agencies in the US. I worked with Closer on a few projects, worked with the UKDA in the past, and lots of, that's the type of agencies we deal with. We've been doing that since the late 90s. I actually used to work at the World Bank, and then later on did some consulting, and we formed a group at Metadata Technology. Our skills are more, it's kind of a mix of information technology and data management. Most of us have a background in IT, but we over time clearly became pretty good data engineer, data scientist, or whatever you want to call us. So I'm joined today with two of my colleagues, Andrew DeCarlo and Carson Hunter, that work that are leading a lot of the work around the Rich Data Services platform. So the topic of the day is Rich Data Services, and I'm going to go a little bit of background about what is that platform trying to do or trying to solve. And in a nutshell, it's two main things: is data wrangling and modernization of infrastructure. In the traditional environment, which is mainly our day-to-day life, we find that the data lives in many different formats. You'll find data in text files, in database, in proprietary files like SAS data, SPSS, and many other variations. And at the top of the screen, you have the users, which mostly are typically statistician or data scientists that on their end use a variety of tools, SAS data, SPSS, R, Python applications like that. And they spend a lot of time trying to, not only trying to find the data, but also trying to get the data in a shape and form that they can use. And they spend a lot of time doing data wrangling, which is data conversion, transformation, tuning things, tweaking the data, subsetting, and things like that. That's kind of the big problem. On top of that, there's a couple of other things. There's obviously metadata, which is often not really next to the data. When we mean by that is all the knowledge around the data, the code book, the documentation, how the data was produced, the provenance and things like that, which can sit in documents, but also sometimes just in people's head. And that's often hard to find and not with the data. And there's also another group, which is the web and applications developers that we often don't pay lots of attention to, but today are a big data consumer. And these guys have a hard time actually even accessing things like database or SAS or SPSS of text files because they live on the web. And typically they don't interact directly with these things. So what Rich Data Services is trying to address or is addressing is these things by changing a few things. And one is the idea to connect these user and application to the metadata and the data using a web service or an API, which is a standard technology, has been around for many, many years. And in order to do so, there's two things we do. First, we move the data from the files, whatever they are, CSVs or a thing, into databases. We also have, and this has been the focus of our work for many, many years, we obviously also put metadata next to the data. And the thing we do, and this is not something we've invented, obviously, it's been around, the idea of having metadata next to the data has been there for many years. We convert that knowledge into machine-friendly format and as much as possible based on standards, in particular standards like the Data Documentation Initiative, SDMX, which we've been involved in the past in terms of designing it. Once you do that and you have these data and metadata in database, you can expose that through a web service, a standard API that then both data scientists and statisticians can access to either interact directly with the data, especially if they use modern tools like R and Python that can easily interact with APIs. But they can also download the data for offline analysis in open formats, and we'll do a demo of that today. This obviously also is a natural fit for web developers and application developers that now can concurrently access the data and the metadata through a web service, so they can essentially get the information they need with a minimal amount of effort. And the idea here is to extensively reduce data wrangling, facilitate access to the data and the metadata, and also modernize in general the infrastructure. So the first question we typically is why do you want API? And API is something really has been driving the internet and the IT revolution for many, many years. So it's first about modernization. You'll see that a lot of data management infrastructure have a little bit behind in terms of upgrading the system. And it's kind of really time to bring these things to the 21st century. As soon as you have APIs and web services, you're starting to enable discovery, access by computer systems and software rather than by human beings, which obviously brings a lot to the table. An important thing of API for us as well is to what we call cater to the next generation of data scientists and statisticians. The people working with data today that are in their 20-year-old, 30-year-old, even teenagers, they're born with IT, and it's a natural fit for them. And they actually sometimes surprised with there's no web service. I'm starting to see questions like what is SAS, what is SPSS. They may not even be familiar with some of these data formats. So catering to the next generation of scientists and researchers and statisticians is critical, and API is a step towards that. Another thing is their self-service. Users can now go and help themselves to the data or the metadata, which also reduce the burden to the data publisher and facilitate exchange. And also the availability is basically 24 hours a day. And lastly is to align on standards. APIs are essentially an IT standards, and by adopting API and making your data available through API, you're aligning on essentially IT best practices. The next question is about why metadata. And it's obviously a question that is very important to us. But the first thing is to realize that APIs and giving away data is not enough. You need to give more than that. It's actually, for me, common sense. You will not give data. You should not ever give data without documentation. It's a terrible thing to do. But it often happens. You find a CSV file or other files out there with low or very little documentation, and that needs to be there. The problem with documentation is typically not in a machine-friendly format. It sits in a format that is a document or a PowerPoint or an Excel file or a PDF that machines have a really hard time to read. And there's a lot of documentation that simply is not out there. I say it sits in emails on people's head. By turning that into machine actionable or format that are machine friendly, then you give also the power to computer systems to understand the data, to do something with the data, whether it's for quality assurance, processing, analysis, which in turn enable automation. Now suddenly things go faster, go better. They're no longer prone to human errors or typos and all those type of things. So essentially you give to computers the power to understand and deal with the data, which automatically also has a tremendous impact on data and research quality, simply because by delegating a lot of tasks to software, there's lots of things that we don't do very well that can be done by machines better and faster. Though the analysis is always obviously what interests us. By doing this also, you can start spending much more time on research and analysis rather than spending time data wrangling or doing repetitive tasks that you're not supposed to do. Finally, it's also aligning on standards. I'm sure you probably heard a lot about standards such as DDI and SDMX and JSIM. By adopting metadata, now your knowledge is in this format that are basically based on standards. So why RDS? And RDS, Rich Data Services, essentially is an API that brings these two things together. So it's not just a data API. There are other platforms out there that will give you data over an API, but you often going to see a few things that they lack metadata. That's definitely one of the weakness. And also it's not always pretty much catered, very well catered for statisticians and researchers. So you're going to find API, but we designed the RDS API based on many years working with data. So there's a lot of features in there that help you access the data, discover the data, and work with it. RDS has a pretty wide user ecosystem, both on the publishing side and the researcher sides. Whether you're a developer or an end user that needs UI, we have a few options for that. It obviously tries to stop data wrangling, which is something that we are trying to address. And in addition, we find that our platform is extremely well documented. We take pride on that. Carson, that is on our call here, is putting a lot of effort in that. We also work with a company called Postman in terms of making sure the API is documented, not only using open API standards, but also tools that developers use all the time. And the platform is also backed by our team, which is not only an IT team. We describe ourselves, as I said, as both data scientists and technologists. So we understand both sides of the problem and on the system. This is a slide that I will skip over. I will leave it in the presentation. I will illustrate the different audiences and the user ecosystem for RDS, where you have the publishers on the top, the web developers or data scientists on the right, and kind of more the end users on the left-hand side, the end users being more the ones using user interface or dashboards that are kind of typically built by the people on the right-hand side here. So the services being offered by the platform are broken down into 4 pieces. First, we have kind of catalog and what I call catalog and data product services, which is really the metadata piece, where you can go and find a catalog, find the data set that interests you, describe the variable, describe the code book, the classification, and their related properties. Then you have data querying services, which is where you can either interact with the data, either subset the data, tabulate the data, and these type of things. Whenever data comes back, you get metadata with it. That's one of the key pieces of the platform. So data never comes without knowledge. It's an important aspect of it. Then we have what we call the open data packaging services. We understand that not everybody will work with an API, and a lot of people want data offline. And so we package data in a way that is not just one file, but more a package. We'll show that in a few minutes. A package of files where you have the data in ASCII and CSV, but you have the scripts and programs to go with it. So you can load that directly in your favorite software or in a SQL platform. And then obviously we have some administration utilities for the management of the platform itself. No, it is an API first and foremost, but it also comes with a few user interface because not everybody is a API users. It's not only for demo purposes, but also to be able to use the platform. We have 3 tools. One is the RDS Explorer, which you will see today, which allows you to browse the data and explore the data in the metadata and subsetting and download. We have a tabulation engine to create quick tables over the data. And we have the RDS Manager, which is kind of a platform software mostly for RDS administrator to maintain the content. But the key thing is these 3 applications are just 3 things we build on top of the API. What's really important is for you to build your own thing. That's the key. So you want to build your own application, your own dashboard, your own storytelling visualization. You can integrate in your web portal, in social networks. You can access directly from R and Python and Java and C because the API is there. And mostly we always say just imagination is your friend. It's an API. Whatever you want to do with your data can probably be built on top of an API because you have access to the data and the metadata. There's a lot of things you can build. So an idea, it's important to see that RDS comes with a few user interfaces, but they're just there to illustrate what you can do. If you go on our website, we have a few of these out there. We have a few showcase where, for example, we have dashboards and little UIs and little graphics built on top of RDS. We're not going to go into that today, but these are available on the web, so you can see a little bit, some things that you can potentially do with an API, and that's all there for you to go and play with. So now I want to get more into a quick demo of some of the things you can do with RDS. I'm probably going to do only 2 of them today, not 3 of them. I will show you the RDS Explorer, which allows you, as I said, to browse the data, do subsets, and download the data. If we have time, I probably won't. We'll quickly show the tab engine. And then I will pass to Andrew, who's going to do more kind of an end user analyst demo about how you can, for example, access data and metadata from R to, in a matter of a few minutes, create a visualization and a Markdown application using R. So I will jump into that now. I'll do my part and then Andrew will pick up. I will bring this screen here. And I will go to this RDS website. So to showcase RDS, we've released a couple of data centers out there. One is, they're public, anybody can go. You're welcome to go and use these data centers. One is around COVID-19 data. We took data sets from Johns Hopkins, from SAS Canada, from the US government and elsewhere. We publish them in RDS, and we also put this out there because we thought it's important for people to have access to these data sets through an API and with metadata. But for the purpose of this demo, I'm going to use one data set from Canada, which is their labor force survey, which is updated monthly. And it's a public use file. So I'm going to go from here and go to the RDS Explorer. The first thing you see when you open the Explorer is a little catalog of data sets that are available to you. So I'm going to go to this and go to the Canada data set. We have a few series there. We have COVID-19 data. And I'm going to scroll down and use this labor force survey. So this is a monthly labor force data in Canada where you have, how many people are employed and not employed and these type of things. So the first thing I see here when I jump into the application, I actually see the data records. So I'm actually browsing the data set. The first important things to realize is that you're not browsing data, you're actually browsing metadata without probably knowing. This is probably what you want to see. But if you would actually get the original data without metadata, you will see something like this. So basically, this is the data. This is the data with no metadata. And you kind of guess that this is a province. It says this is an age range, that this is a survey year. But if you don't know what these codes are, well, here we go. You can start data wrangling and find the documentation. Because RDS offers both at the same time, I can display the code labels rather than the code themselves, or both together at the same time. And this is true for obviously any categorical variables we have in the system. So this is data and metadata together. And there's a first important piece is that whenever you interact with data here, you get at least the information you need to use it directly. So this is you can see the records. There's 3.5 billion records in this. I think you go from January 2018 until the January month. I just upload the new data. So you can go on the data set, you can click on the individual variable, and then you're starting to see what you would probably be familiar with as a code book. You can see the variable, the label, the data type. You can click across the different variables. But if you want to see your codebook data dictionary directly, you can go to this tab. It's similar to what you see in SPSS and different type of thing, but except now you have all the metadata with it. So you can see this is the data dictionary, the different variables that are in this data set, the 61 variables you can see here. So I can browse the data. I can look at the data dictionary, and I'm in Alberta, Canada. So let's say I'm a researcher in Alberta, Canada, and I'm interested in this data, but not the entire data set. I don't need the two and something years and the data for all. So the thing I'm going to do, I'm going to look at the data, and first I'm going to go to the survey year and say, well, I'm interested in 2020. So I'm going to go to the filter and say the year that interests me is 2020. And you know what? I just upload January, so I'm going to take 2021 with it. And now I'm going to create a subset of the data here. So now I apply this filter and I'm done. You can see at the bottom right here, if it's not too small, there's no 1.1 million record. As I mentioned, I'm in the province of Alberta. So I'm going to click Alberta, apply a filter here. And let's say my particular research interest is for individuals that are 20 to 30 years old. So I'm going to add a little filter here. And another thing, I'm interested in female that are 20 and 30 years old. There we go. So I'm going to do this. And I can keep filtering the data. And you can see as I apply filters, my number of records is now about 7,000 of them. So I'm happy with this. This is what I want. But the other thing also, I don't need all the variables. So these are all the variables in the data dictionary. I'm going to take the year and the month. I'm going to take the labor force status. I don't need the province because I'm in Canada. In Alberta, sex, marital status, education. What else can I add in? Oh, this is a weighted data set. So I'm going to put the final weight. So I have 6 variables. And I'm going to put my age in there. So now I have the 7 variables that interest me. So I can go back to my data pane here and I say, well, what do I have selected? So if I say selected here, this is the actual subset of data. So I'm looking at my 7 variables and 7,000 records. That's the data that interests me for my research. That's what I want. So now I'm going to leverage. So by the way, this is all driven obviously by the RDS API in the backend. This is just a user interface on top of RDS, leveraging the web services. So now I'm going to use the other piece. I've mainly been using the data querying and metadata services so far. Now I'm going to use the data packaging services. And I say, okay, I have 7 variables, 7,000 records. I want that on my machine? No, because I'm going to use this in SPSS or STADA. So I'm going to pick a couple of formats. And I'm a data scientist, so I'm going to pick SAS data SPSS. I'm going to select that. And I'm going to add a couple of these little things. One is going to put a PDF codebook, and because we have metadata people around, I'm going to put the DDI metadata codebook version 2.5. I'm going to select this. And now I'm going to tell RDS, you know what, package this and give me a zip file. So I'm going to package it, know the system is going to the database, generating a few scripts and things like that. And in a few seconds, I have this subset of data, which is important. So I don't need these 3.5 million records. I'm going to download this on my machine. And it's going to put a little zip file on my computer here that I'm going to go and look at. So, I mean, the other package, I just don't know that this zip file, and I'm sorry, I cannot make this bigger. This is unfortunately something I can make bigger. But I don't know this little zip file. So if I open it, I'm going to get a collection of files here. And the first thing I'll find in here is the data in CSV format. So if I open that, and this is big as well, this is essentially the data set, but I only have, and this is the data, there's no metadata, this is the actual data with the 7 variables and the 7,000 records. So I have the data in CSV, which is great because anybody can read this. But now, of course, I want to use this in Stata or SPSS. Well, actually, what we do when we do open packaging, I generate an SPSS script because we have the metadata around the data. I generated this SPSS script for you. So you can actually, let me resize this window a little bit. And if I run this script here, this is going to load the CSV file in SPSS, as well as create the code and the categories for each of the variables. And you can see where this is going, because, and that's one of the powerful thing about metadata. You can start generating code for a lot of people. So I will have the same thing for SAS. If I want to read the CSV file in SAS, well, this is the SAS code that will read that file in SAS. And the same thing for Stata. An important thing is you don't have to retype any of this. And in this example, I only have a few codes in my classification, but some of these code lists can literally have thousands and thousands of code. You never want to retype that. I guarantee you'll have typos and mistakes, and you'll spend a lot of time doing that. And if you find the code book in Excel, well, guess what? That's probably what people do all the time. And users will spend hours and hours rewriting code that should never be written by hand. A couple of other things I have with this is I have a DDI XML file, which some of the metadata people on the call will recognize. This is kind of an XML file with, which is essentially an XML version of the codebook. If you live in the standard world and deal with metadata, you'll see a lot of these things quite a bit. So it looks like, oh, I have all the files open here. There you go. So it looks something like this with it's kind of a codebook XML. And finally, I have a PDF codebook that has been customized for my little subset here. So instead of having the big codebook for the 61 variables and the 3.5 million records, I have a little PDF file here that describes my data, give me how many records, how many variables. I have a little codebook, and then I have summary statistics with the statistics updated for my subset for the data set I just created. So this is just an example of using RDS as an API, an application front end, to bring data to your users. They can browse subset and download in open format. There's obviously many other applications, but it's something we like because I think it fits the need of many users as well. So that comes with the platform. So now I'm going to pass the demo to Andrew. He's going to show how you use RDS in R. To introduce this, we're going to be using the Google released mobility reports as part of the COVID-19 initiative. It's basically a data set that shows where people go based on their cell phone. It's Google spying on you and making sure everybody knows where you're going. This data set was actually used by an article in BBC recently around trying to figure out if people were breaking the lockdown in the UK based on they're just supposed to be home, but maybe they're actually going to restaurants and parks. So it's a data set you may have seen before, but again, it's something Google makes available as a CSV file and a few PDFs. And I think that, if you want to use this data set, well, you're going to do some data wrangling. You're going to download the CSV, create a code book, and all those type of things. So we publish this in RDS, so it's instantly usable. So I'm going to stop sharing my screen and pass to Andrew. I think, Andrew, you can pick up the share, right? So in this example, it's more kind of an end user analyst type of view that's using R. But it's also to see that you not only need data, but also get metadata through the API.
Good. All right. So to just kind of illustrate what Pascal was talking about with these APIs, I decided to make a little R Markdown presentation about this Google community mobility reports. And I'm going to go through what I have as the output here, and then I'm going to dive into some of the code. Hopefully it's not too technical for everyone out there, and we should be able to see what we get back from the API. So again, I'm doing this in R just to give you a kind of a taste of how something could be presented and designed from an end user, and then to show also the informational objects or models that we get back from the API. So here I've got just a little HTML report about the mobility reports, and I've got some descriptions about what this is. Pascal just described, it charts the movement trends by geography across different, categories of places. So retail and recreation, groceries and pharmacies, parks, transit stations, workplaces, and residential locations. And then I've got a little bit of information here that'll be useful to us as we look at this plot down here. So I've got the data from RDS, and I'm showing the change in mobility across the retail and recreational facilities in the United Kingdom right now. And so we could go and move around to different categories that they have here and take a look at the data that Google's collected. And that's going to show us kind of the trends and where people have gone in these different places. So typically, a lot of people started going to parks more once things got locked down, and they've since decreased that. And we can go look at all these different categories and so on and so forth. This is all coming from the RDS API, so we can change the countries here too, and maybe compare it to the USA or something like that, and see how these different places changed in the different countries that were captured by the Google reports. So what are we actually looking at here? This is a change in mobility in percentages, but what's the baseline? Well, that's kind of the documentation of metadata that's around the data. And so we'll see in these notes here that Google defined the baseline as the median value for the corresponding day of the week during a 5-week period from January 3rd through February 6th of 2020. So that gives us kind of a context when we're looking at the data about what are we actually comparing against as we go through this different the data points here. So all this stuff, all this information here is coming from the RDS API. We've got the metadata here around the actual data product or data set that we're looking at. We've got the different countries that we can look at, which comes from a code list that we have documented in RDS. And then we had the variables that we can pick from to look at the different change in percentages. And we selected these based on some of the metadata that's come back from the API. So I'm going to go jump into the code here real quick and kind of describe where or what the API is doing and where we can get this information from. If to do that, I'm going to open this environment section here real quick. And this is going to have kind of the objects we get back from the API. So I'm going to actually run my code over here. And this first 3 lines here are just connecting to the server and getting the data product or the data set back from the RDS API. So I specify which RDS instance I'm going against, pick out the international catalog that we have there, and then from that catalog, I'm grabbing the Google mobility reports for the different countries. And so we get these 3 objects that come back here. I'm going to look at the data product here, and we'll see what we can have coming back on this thing. So this is an object that we return, and it's got the ID of the data product. It's got the citation information, a description, a label if it's there, the last time it was updated, the name of the data product, and then any additional notes that might be useful to people. So we can see that all I've had to do here on this output is print these things out. I've got the name here, the date that it was last updated, the description of what it is, and then I've added the additional notes here to make it easy for people to see what they're looking at. So that's just that. This is the area that I'm actually printing that out, so just formatting the output. But the next thing I can do is get the variable metadata from the API. So if I open this up, we've got a list of variables here. And we're going to see that we have a lot of metadata for the variables as well coming back. We've got the name, the label. This is the country code, the 2-letter country code. We've got a description of what it is. And because it's a code, it's got a classification or a code list that's associated with it, and it gives us the ID. and the URI of that. So that's just a couple ways to identify what classification it's using. And we'll take a look at how we can get that information back in just a minute. It also has some information about the variable itself and kind of the roles that it plays. So we'll see that this is marked as being a dimension. Is dimension is true. And what that means is pretty much like the different measures or the different percentages that are part of this data set can be grouped by this variable. So you could aggregate that information by this variable, by the country. It's not a measure because it's a dimension. It's not required, and it's not a weight. So we have these other kind of informational aspects about the variables that can help people determine how to use that. And we'll take a look at how we use that in just a minute for the measures there. We also have a date, and then we've got all the percentages that were provided in the reports. So if I wanted to build this drop down here for the countries, I wanted to just grab that country code and let people filter based on that. So I have this little call here that's going to access that country code list from the RDS API. I'm saying I want the classification for that first variable there, and I use the URI to specify which one that is. So if I look at that, that's going to be a table of all the code values and their names and a couple other pieces of information that might be useful. So we'll see that we've got the code values here and then the name. And I use the names to populate this drop down here with all the kind of the more presentational view of the codes. Again, I wanted to let people choose the variables they were looking at. So this measures section here is just the variables that you can choose from to display in the chart. And so we have the percentages of change that are all listed here, but we also had that country code and that date variable in the variables. And so I don't want to show those here because that doesn't really make sense. You can't chart the percentage of change of like a country code. That doesn't make sense. So what I did is I actually used this little block of code to iterate through all the variables and check if they're a measure. And then I could just dynamically build up this list and present that to users with information that makes sense for them to be able to select from. So by using both that classification and the country, or classification for the countries and the measure information on each of the variables, I can have a dynamic drop down over here that makes sense and actually doesn't really need to be updated. If there was a new variable introduced to this data set that was another measure, or if for some reason they didn't have a complete list of countries in the past and they updated it to include some new countries, those changes would just dynamically show up in my output because I'm going off the API. The same thing for, any new information about the notes on how to use that. If someone added some new aspect of this data that was important to know, because I'm getting that metadata from the API and I'm not handwriting it myself, if that gets updated, my interface that I've designed is going to reflect those changes. And so it kind of gives the users or the developers a way to be able to consistently show all the information that they need for the users to have kind of informed presentation. So this is just kind of just an example of what people could do with the API. We also have, this is written in, we have an open source library for interacting with the API in R, which we also have for Python and JavaScript. But if something like that didn't fit your needs, you could always go against the API directly. That's what these open source libraries are doing. And so it's just kind of a convenience layer on top of the API. So I think that's it for me.